We've done a couple things here. One is we've built a lab mock-up of an actual cell site. So we've got Nokia radios, which don't work, but you can see, yeah, these are the Nokia radios. You can see where I can put dummy terminators on them, so I can actually fire those up. I can't put the antennas up, the FCC would arrest us. But I can put terminators on them, and we can fire them up so that I can have the radio loads. But we've actually done that in doing some tests for major clients for configuration and whether or not we can cool it under the actual radio loads, that sort of thing.
So you heat it up with the radio loads, and you test it before the customer ever takes it out to their site.
Right. So we know what it's going to do in the cabinet and what our configuration that we're configuring for.
And you can work with whatever batteries we have in our network.
Absolutely.
Okay, I've seen the solution.
As you can see, these down here are the red ones are a particular brand and type of battery that's used. It's lead acid, but it's used in the high temperature type environment. So we get a little more temperature variance out of those guys. And we've got a major customer that we evaluated those, recommended them, and they use them. We've got the power plant, DC power plant. We've got heat exchanger in the door and thermoelectric coolers in the bottom of the door for the batteries to keep the batteries cool.
Okay.
And this is the equipment side of the enclosure. So that takes care of the box, and this sets out on the cell sites, and we've got literally hundreds and hundreds of these that are deployed. Then for the alternative energy side of it, we have brought in solar. We've got 48 volts worth of a solar system up here, and we actually run it off a metal halide lighting system. And also wind turbines. All of it connects back to this cabinet, so now we can evaluate and figure out what we want to do as far as switching, how this reacts with that, and fit them all together and make them work homogeneously together as a system. And that's what all this is about, is the experimentation, discovery, and development of advanced power. Starting over here, you can see I've got two big rheostats controllers here, so I can control the speed of the turbines. And over here on this bay, I have the controllers. This is the two turbine controllers. This is the solar controller that's tied into my power plant. So all of this equipment, including this rack, that rack, the whole bit, all connects to the same bus as the rectifiers do. So the batteries are another load on it, just like the radios are down in that cabinet, right?
Getting the flow.
So all of that stuff connects together, which is what we're trying to achieve here, is an uninterruptible source of power. So if I've got solar, I can use it. If I've got wind, I can use it. If I have the two of them together, I can proportionally use the power available from both of them. If I don't have enough power in the solar and wind, or no power in the solar and wind, I still have AC in my rectifiers. So I'm back to a conventional run rate. So that's what all this stuff does. Now when I turn these on, they're going to get a little noisy. We'll turn both of them on, and I'll just kind of throttle them up slowly. So there's maybe 4 or 5 mile an hour wind.
So that's a 4 or 5 mile an hour wind?
Yeah, about that. It's about that much. So now, if I have a gust,
wow,
that sort of thing. So now, if I apply those to the bus, you can see it stalled.
Yep.
I didn't have enough wind to keep it going. So right now, the whole mess, everything you see in this cabinet, including the heat exchangers, all the lights, TEs, everything is running off of those two turbines and that solar panel. And we're recharging. We've got 3 strings of batteries online, so I'm recharging 3 sets of batteries now. And if your battery's big enough, it'll run whenever it doesn't meet your needs. You just run on the battery. You don't need to use any commercial electricity. So you could do a complete off-grid. And you don't have to have 8 hours of sun a day and 20 hours of wind a day. The difference is the battery. However much sun and wind I don't have, I replace it with battery. Now a lot of people say, oh my God, that's expensive, but some of the new technology we're working with, we're up to almost 10 years in life expectancy with a maintenance factor approaching 0. All we need to know is what your loads are. We do a study based on the location, so we know what to expect as far as sun, wind, the environmental impacts of powering one of these guys. And the rest of it is just engineering calculation.
Telect.